All right, good morning, Kenya gets to continue. Thank you for staying with us. My name is Vivian Ndegwa, and now we get to talk matters health. And today's conversation, as I had mentioned earlier, is quite interesting. I am intrigued by it. We're talking about longevity and genes, and is it possible for you to increase your lifespan simply by looking at your genes and finding ways in which you can eliminate your risks for you to be able to live longer? So that is what we are talking about today, and I am more than pleased to be joined by Samuel Oliech Omolo, who is a PhD researcher and the founding director, the Pan-African Institute of Genomic Sciences, and he is also the chairman of the Li-Fraumeni Syndrome Association Africa. Welcome to the program.
Thank you very much for hosting me. It's not the first time here.
Yeah.
It's familiar. And Jambo Kenya, this is a good debate that we want to take forward on longevity. I come from an institute called Pan-African Institute of Genomic Sciences, recently registered by the Kenyan government, and we are grateful to our president for registering a new state department for research, science and technology with the PS, and this has made us come out. Science is actually taking its position in the country as a part of solution for our world.
All right.
Yes.
Let's get into the conversation. And
Yes.
I want us to begin from the point of just defining what longevity is. So when we talk about longevity, are we talking about, from the genomics point of view, are we talking about your lifespan in terms of how many years you live on Earth? Are we talking about how many years you get to live on Earth as a healthy person? Or are we talking about both of them?
That's a good question. Longevity is how long you live on Earth in a healthy way. Yeah, you can live to 100 years, but you're not healthy. You have dementia and you don't remember anything, or even to 80 and you're not in very good shape, you don't remember anything. So longevity is both how you live for long, in good health, and also a technology. There's a reason why I describe it as a technology whose time has come, and we'll get to know more about it as we continue our discussion. So human health has been more of reactive as in the past, and we look at health today as something that we should be more proactive. Yeah, it's reactive because you get sick, you feel a hitch, you want to go and see a doctor, they react only to what you're feeling. But in modern day, what we are proposing to increase longevity is that we look at predictive kind of medicine, picking it early. If you look at the average lifespan of a human being, human beings are wired to live naturally in their DNA for 100 years plus. If you look at other animals like dogs, genetically, they have an optimal lifespan of 30 years. But look at 200 years ago, the average life expectancy was 30 years, which is different from today, which is 65 years, but in the developed world is 80, 85 years. That's because of technology. In the past 200 years ago, people were dying of infectious diseases. Very simple, cholera, flu virus. But with the advent of technology, where vaccines and antibiotics came into play, all these were eliminated and life expectancy increased tremendously. So how do we increase life again? It's not by changing anything or editing anything. It's simply for we to get into 100+ club, is following technology. We are a blessed generation. We live in a generation where there is high-end kind of technology in DNA sequencing, in imaging and genomics, in biomarkers, in liquid biopsy. Putting it together with the big data and AI, we are able to do what we call efficient predictive medicine, which enhances life.
Okay.
Yes.
Before we now get into that bit, whereby now you are able to predict and get to enhance your life. I want to get back to the life expectancy bit. You mentioned that we are genetically wired to live up to 100 years.
Yes.
But when you look at our lifespan, it varies depending on the geographical environment you're living in.
Yeah.
So in Kenya, the life expectancy, just from a quick Google search, is about 63 years, compared to a place like Japan, which is 81 years. So what is this dependent on? What is one's lifestyle dependent on? Is it dependent on lifespan, rather dependent on? Is it dependent on environment? Because of the fact that, you know, in this country it's this amount of years, this other country this amount of years. So is it dependent on the environment? Is it dependent on our lifestyle? And how much of it is dependent on our genes?
That's a good question. Genes play a role in longevity, but environment plays a bigger role. I want to make it as simple, not very scientific, so that someone in the village...
We all understand.
Yes, would understand this. So genes are like guns. So you load the gun, but environment pulls the trigger. So the environment where we live and the food we eat and all this plays a bigger role in longevity in some areas. For example, you look at the life expectancy in Japan, of course, they have, some of them have more expressed longevity genes like FOXO, but they've kind of food they're eating, may make them reduce their risk towards diseases. What makes people not live for long are basically diseases. And genes are like bulbs, and switches. But environment acts as a factor that switches on or off certain genes that make us live long. So yes, environment plays a key role in longevity. And look at Africa. Africa is a tropical kind of climate. And you look at the northern part of the world, which is more of a freezing zone, you'd find that most microorganisms do not thrive there. They're more in a refrigerated state. But in Africa, temperature is optimal for all viruses, all bacteria, all fungus. So you're always bombarded, allergens. So you're always bombarded with high-risk diseases. So environment plays a big role in the question you're asking. Yes.
So environment also plays, it actually plays a bigger role.
It plays a bigger role. Everyone has good genes, but environment and diseases plays a major role when it comes to longevity.
What role does lifestyle play for someone who's always ensuring they're doing everything they need to do? You know, I wake up, I go for my run, I watch what I eat. I actually have a nutritionist who, you know, directs me in what I am to eat. Am I at a position to live longer than someone who is just living, as we call it, la vida loca?
Okay, that's a good question. Everything from spiritual care in your mind, your whole body care, exercise, plays a greater role in longevity. But we have to look at the whole human body in what kills more people in the 21st century more than any other thing. So we are more aware over time with technology what harms human beings. So there are 4 pillars, major pillars that are away from infectious disease, which has been quote-unquote eliminated by vaccines and antibiotics. What kills people the most in the world right now is cardiovascular diseases. They top the list, followed by cancer, and then diabetes, and then mental kind of related Alzheimer's, Parkinson's disease. So if we are able to manage these ones, these age-related symptoms, and do pre-symptomatic screening early enough, if I can screen early enough and get to know my risk early enough, I'm able to add 10 or 20 more years to my life. And this is where we are proposing a model. The current model does not work in healthcare, where we have sick care model. get sick, we care, and you're taken to hospital, it does not really work. But we also have the current one, which is pre-symptomatic screening. Yeah, we are a lucky generation. We are living in a generation where to live to 80 years, you are in a well state, 60% in a transition state, then you get sick and you die much earlier. But we are proposing a model where data-driven model, where we have 80% of your life, you're living well, and then we have just like 10% to a transition, and maybe at 2% you're sick, and then you die peacefully at 100 years. So these are kind of synergies we are looking at to create wellness, for longevity. Maybe just to take you back, because we are talking about genes. Someone at home may think genes is the kind of jeans I'm wearing. Genes carry biological information. They are within our chromosomes. My mother donated 3 billion letters to me, and my father donated 3 billion letters to give 6 billion letters that defines one person. And these things carry biological information. They carry information about your health, disease risks. Almost every disease is related to a gene, because genes translate into proteins. It carries information about your height, your strength, your eye color, your teeth, everything about you. So once you decode the information that's in you, it's easy to predict your risks. And just taking you back to history so that we understand this much better. 25 years ago, it took over a decade to decode the human genome, to read out a complete human genome. And it was a cost of almost $3 billion. That's a lot of money. But
25 years ago?
Yes, 25 years ago. But technology in DNA sequencing has evolved that today, as we speak, you can, I saw it from Broad Institute and Roche Diagnostics, you can now do whole genome sequencing within 4 hours. This has revolutionized so many things within 4 hours. And the cost has also dropped tremendously from $3 billion. Now you can decode a whole human genome within 4 hours for $200, which means if you want to live for 100 years, you don't need to wait to be sick to spend over 50 million Kenya shillings, bedridden and not working. You better spend $200 US, which is like how much in Kenya shillings?
24,000 Kenyan shillings thereabout.
Yes. So $200, if you divide by 100 years, is $2 per year. To sequence your whole genome, which is again done once to gather all the biological information within you. You will not repeat it again because it decodes all the information in you. So this has reduced significantly to an extent that now genome sequencing in 2026 into the future is getting into the clinic. And it's going to save lives. But it's not only genes that determine longevity. Could be to what human beings understand, 20 to 30%. But there's a major pillar that we are dealing with, which is cardiovascular diseases, respiratory diseases, talking about cancer. So if you combine what at Pan-African Institute of Genomic Sciences, we are coming up with a product called Symphony Clinic, where we are using whole genome sequencing, rapid sequencing, imaging using MRI, magnetic resonance technology, which is almost in most hospitals in Kenya. And then we're also looking at the biomarkers, like you do whole blood screening, hematology. And then you do liquid biopsy testing using PCR for circulating tumor markers in your body, risks within your body. All these combined as a symphony, using AI and big data to analyze this data, we are able to predict accurately what's affecting you as an individual. Okay. Your risks as a family could be cardiac arrest in the next 10 years. Mm-hmm. If I look at my whole data within the symphony, I could be having a risk of high levels of cholesterol or a heart attack. Mm-hmm. So once we know our risk, what we call Achilles heel. Achilles heel, layman's language, is your fatal weak point. Once you know your fatal weak point, you are able to pick it out and resolve it. And by resolving it, you are 10 or 20 years ahead of your time, okay, or reducing that risk. If I'm able to pick that I have a high risk for lung cancer in the next 20 years, with that data that I have, a doctor anywhere, not necessarily within our system, is able to tell you, choose the Charlie T. Munger principles. Charlie T. Munger is a philosopher who lived to 99 years, but he said, in a funny way, if you tell me where I'm going to die, then definitely I'll not go there.
Of course.
If I knew I'm going to die at KBC, I would not come here in the morning. I would stay at home.
Sure.
So the moment you know that your risk, your point of death is going to be heart attack, or lung cancer, or a tumor that's caught at stage 1, which is still 1 centimeter, you're able to work with your doctor. It could even just be a polyp that's just removed, and you add 10 or 20 more years to it. All this system contributes to longevity.
All right.
So longevity is not just about strong genes. You can have strong genes, but environment plays a very big role in your daily life, and it can reduce your lifestyle.
All right.
Yes.
So what I'm getting from your explanation,
yes,
is that I can be able to tell what condition or what disease may affect me in future. You can easily tell, like if I come, you've called it genome sequencing, right?
Yes.
The genome sequencing, the MRI, and all the tests that you've just mentioned.
Yes.
If I come to you and, we get to check, can you tell if maybe, God forbid, I have a risk of developing maybe some sort of cancer in the next 20 years? Can you tell?
That's very easy, very easy to tell. Everything is in our DNA. It's like carrying information with a flash disk. Remember, biology has come of age as a digital science. Yeah, in the past, we were talking only about computer. Computers works with 0011, yeah, for codes. But human DNA is just the same. It works with CTG, yeah, all those, yeah, adenine, cytosine, guanine, and thymine, ACTG, yeah. So you are able to, once you decode everything in your genome through whole genome sequencing, which I have to emphasize has become very cheap, and it's going even cheaper into the future, you are able to predict your risk for example, for cancer, for cystic fibrosis.
For any kind of disease?
For any kind of disease that's genetic. For lung cancer, we have, if you go even right now to our major hospital, you hear doctors talking about lung cancer markers, yeah, cancer panels. It's called a whole panel. You're able to do a whole panel and get to know which one. Is it pathogenic, which means disease-causing risk, or is it just a silent one? So once you know you've done whole genome sequencing, and you analyze, for example, you pick and you know that I have a pathogenic mutation in TP53 gene. TP53 gene is the guardian of our genome. It's like the police of the human genome. It proofreads the whole genome and get to know where the genetic mistake. And you're told you have a pathogenic mutation in your TP53 gene that's predisposing you to high risk for Li-Fraumeni syndrome and cancers. Yeah? So from there, you were able to deal with it. And a good example, we have people who have come out, they're very vocal about their genetics. Look at Angelina Jolie.
Oh, yeah.
She talks about BRCA1 and BRCA2 gene, and she's made the breast cancer awareness space very big using genomics. Yeah. In Kenya, I have to give a Kenyan example, of course.
Yes, please.
One of our greatest champion in our studies for Li-Fraumeni syndrome, she's called Lakita Bongo. Yeah. I know she's not new to the Kenyan space. Lakita's father had cancer. She used to work in one of the media houses, I think Nation Media, and he had a mutation in TP53 gene that was not picked, and he died at age 30, yeah, of an aggressive sarcoma. And later on, the daughter, Lakita, got an early onset aggressive tumor. But this was not picked on her treatment until she was taken to India. The sarcoma became very aggressive and her leg was amputated. She lost one of her legs. So down the line, a doctor said within the group that you need to do sequencing, genomic sequencing. And when genomic sequencing was done on this beautiful girl, it was found that she has a mutation, a pathogenic mutation on TP53 gene. This caused a syndrome called Li-Fraumeni syndrome. And Li-Fraumeni syndrome, if you have it, you are almost definitely a candidate for cancer, and also multiple types of cancer. So over time with technology, now she knows how to live well. The moment they knew she has Li-Fraumeni syndrome, she's predisposed to cancer, there's a protocol on how you live well. Guess what? Even after amputation, she's lived well. She's gone through some technology treatment. She got a bone marrow transplant from the mother, and she's now cancer-free, which means information. Her weakest point, the fatal point, was picked out through genome sequencing, and now she's going to university.
I love that, and I want to still get back on that, you know, because it's really intriguing. It's interesting, right? So I want us to use a case scenario of young girl or boy who is now just 10 years old, you know. So can you tell from as early as that young, you know, one's weakest point in the future? So probably this 10-year-old is going to develop a cardiovascular disease when they are 50 years old. So 40 years to come, they will develop that kind of disease. So can you tell as early as 10 years old? Because I mean, when you talk about genes, it's who you are. So you're born with the genes as they are, right? So can you tell from that age, well, from the 10-year-old, if the parent decides I want my child to, you know, to get checked, they do the genome sequencing and all these tests you're talking about, can they tell from that age? And is it possible to prevent this 10-year-old from developing that cardiovascular disease by the time she's 50?
That's a very good question. Genes carry biological information right from inception. So age 10 is even old, even as at birth. Once you take blood or any cell from the human body and you do whole genome sequencing, you have biological information about that child. So once you sequence, there are AI tools that we use to analyze. Remember, in the past, machines depended on human beings to move them around, to shoot. But in this generation, human beings depend on technology and machines, and we are soon depending on them 99%.
With the emergence of AI,
Yes, AI and big data. So you are able to identify your risks. Every gene and mutation and risks for certain diseases are within our DNA from birth. So the answer is yes. The 10-year-old boy, you're able to pick their risk for cardiovascular diseases, for digestion, let's say PKU, from day one, for lactose intolerance, for cancers, and even diabetes from as early as age 1. So remember, the risk is there. The environmental trigger is now what you avoid. So once you know that your child has a high risk, let's say for a cardiovascular disease, it runs in your family. So this child is able to walk a journey with their doctor. Yeah. And once such kind of specialized diagnostics are done, at times it's not very good to work with your family doctor.
Why not?
Because some family doctors are not specialists. Yeah. Once you identify that this is now, I'm dealing with, let's say, cystic fibrosis or cancer risk, now identify a specialist to work with to minimize the risk. Because the family doctor will tell you, it's not yet there. We can wait and observe a little longer. So if you're observing a little longer, a stage 0 tumor could be 1 inch next year, could be 2 inches after a few months, and 8 inches. With that, you lose a life. So the straight answer is whole genome sequencing has come of age. Biology has come of age as digital data, and you are able to pick diseases early enough. But not only with genes. This must be complemented with whole body MRI imaging, biomarkers, and also liquid biopsy and big data, combining all this. And that's why the Pan-African Institute is proposing starting to come out with a symphony for this kind of project.
Wow. Okay. I want to get into this because, I mean, we cannot avoid religion. And Kenya is a very religious nation. So I'm sure maybe there's someone who's maybe thinking in their mind, you know, I mean, life is God-given, and if there are some who believe that when you're born, it's already premeditated when you're going to die. You may be the kind who will die at 30, you may die at 80, you may die at 100, and it may have nothing to do with everything that we're talking about. So what would be your take on that?
A good question. Science has nothing, has no fight with religion. Me, I'm a Christian. Someone is a Muslim, all this. But healthcare, indicators within our bodies have no religion. Yeah, there is nothing ethical that science is flouting. Science is just telling you, hey, this is your high risk. This is your point of death. This is what's going to kill you. Because if you meet people in a religious gathering and ask them a question, who knows where they're going to die? Do you?
Nobody knows.
No one knows in the studio. Who knows in a religious gathering when they are going to die?
Of course, no one.
No one knows, right? But what if, glaringly, you do an MRI scan and you're told you have a 1-inch tumor growing on your bone? Is that something good or bad?
Bad, definitely.
But is it informing you of something?
Yes. I mean, you get to know earlier.
Yes, so that one technology has nothing to do with religion. There's no clash between religion and, this is like servicing your body. A car back in the village that belongs to our grandparents. That's why I want to communicate to someone in Ganze or in Turkana. If you look at vehicles, the 1950 models, the Volkswagens, if you look at the one in the village that was left there, even trees and mold is growing on it. They're completely grounded. But you can find the same Volkswagen in Nairobi that's being serviced regularly. The engine is still running and it's moving around. Are you getting the concept? Predictive medicine is just like servicing a vehicle. The more you service a car, the longer they live. Yes. It's servicing human beings and predicting risks early enough makes this vehicle live longer. And that's whole essence of longevity. So there's no conflict between religion. Religion has its space, very important. but scientific facts about the human body and the frequent service needed combined with your genes makes you live longer. And humans naturally, the human genome is wired to live for 100+ years. Okay. It's only the environmental factors that would reduce this. Yes.
So is that like a lifespan that is already encoded in your DNA?
It's encoded in our DNA.
Oh, okay.
That's why we are different from rats and mice. They have a shorter lifespan. And elephants live much longer, to 87 years. They're like human beings. It's in their DNA. I think there's a species of whale that lives for fairly over 100 years. Tortoise. You go to Nanyuki.
Yeah. I've seen that. I don't remember how old that tortoise was, but yes, I've seen that tortoise.
Without acts of God, like accidents or any other person, a human being's DNA is naturally wired to live 100+. So people should not fear club 100+. You just eliminate your risks and follow the protocol and technology. I can tell you longevity is a technology whose time has come. Like it or not, it's happening in our generation. And we're in a generation where big data has come of age.
Yeah.
Yes.
Is longevity hereditary? In the sense that, there's someone who may say, we live longer, our family, looking at our family tree and all that, we live longer. Someone would say, my great-great-grandmother is still here at age 100, and, my grandma is still there maybe at age 88. So is it something that is hereditary? Because there's one who say, well, I've never even met any of my grandparents. They died earlier. So could it be hereditary?
Yes, it is. Scientifically, it's hereditary. Genes are inherited. We get one from our mother and one from our father. But there are specific longevity genes that are expressed, like FOXO03. These ones, they control stress.
Okay.
And the whole human body. They are more expressed in certain population than other populations. So we can say partly yes, but I think not more than 20 to 30%. We have TP53 gene, which is the guardian of the genome. We have ApoE4 gene, which is for things like cystic fibrosis, Alzheimer's disease, and your whole brain, the way your brain works. So it's partly yes or no.
Okay.
Yes.
Okay. When you talk about gene editing,
yes,
what are we looking at? And is it the same as gene mutation? And can it be used to extend one's lifespan?
That's a good question. Mutations are genetic mistakes that occur within our genome over years. Remember, the human being has billions of cells that divide every second, but they do mistakes. Each cell makes a copy, and it's identical copy of one this side, and makes another copy. So there are genetic mistakes in copying DNA, because the information in one cell should be exactly the same information in the other cell. The information in your cheek cells should be the same information you get in the DNA in your blood or in your hair for forensics. So mutations are genetic accidents that occur frequently within the human cells. Some are good, some mutations are good. It can enhance adaptability, but some are also disease-causing, which we call pathogenic mutation. That is totally different from gene modification or gene editing. Yeah? Gene editing is intentionally modifying a gene, a human being intentionally modifying a gene for a certain purpose. Let's say, for example, you have sickle cell anemia. You are modifying the gene that causes that so that you're producing the right proteins. Yeah? Let's say you are modifying TP53 gene. You are deleting the part which has a pathogenic mutation to ensure that, and replacing it with a good one from a person with a good one to ensure that you're producing the right proteins for the body that do not predispose you to cancer. So genetic modification has been used in the current world. For example, in reversing, let's say, anemia, sickle cell anemia. It's been used in reversing blindness and many other applications. Even within plants, it's been used for producing GMOs. Yeah, that are early maturing, fast growing, producing certain vitamin A and the rest. So there's a clear difference between a mutation, which is an accident, but gene modification is very intentional to, let's say, produce a product or to reverse a certain condition.
Okay.
Yes.
All right. Now that we know that we have a chance at knowing maybe, you know, what could be the dangerous, the dangerous risks that you may have in future, that you can easily get to detect that earlier. I'm sure everyone would love to live a longer life, and not just any kind of life, but a healthy one, you know? You live a longer, healthy life. So where exactly can one go get the, you know, the whole genome sequencing? Are they done in the country, in Kenya? Are they done in specific hospitals? Just let us in on that.
Okay, that's a good question. Remember, we've talked about a symphony. Yeah, not only one test. We have 4 pillars. We have genomics, we have imaging, we have biomarkers in blood, we have liquid biopsy, and then we have AI in analyzing all this data to give results. So these are technology that's with us. Even at the Pan-African Institute of Genomic Sciences, we have an advanced genomics lab with automated DNA extractors, PCR machine, and a sequencer. We have a portable sequencer the size of this phone. So this technology, DNA sequencing, is already here with us. So you can go to all the big hospitals around. They would offer the tests. You go to all the big laboratories around, they will offer the test. But genome sequencing is different because you are reading out the whole information in you. So there are institutions in Kenya, like let's say KEMRI, we have Aga Khan, Even within the pharma industry, we have, I don't want to mention them because that's commercial. I come from commercial background, so we have to be very careful when mentioning names. DNA sequencing can be done locally. Yes. And within our program, if let's say you come to Pan-African Institute of Genomic Sciences, we program you through we do for you whole genome sequencing. Then you go to a clinic and do full body MRI. You go to any government hospital, even Bagadi, Kenyatta, even you can do hematology, whole blood scan. And then liquid biopsy is what we are talking about, just PCR. During COVID, the liquid biopsy was the first thing. So the footprint of PCR machines in this republic is very big. So liquid biopsy can be done. Where the rubber meets the road is now analytics and predictive medicine, accurate prediction. You can have, there's what we call the accurate area. Are you getting it right or getting it wrong? The technology is there. Look at a case of lung cancer. All these technologies are in Kenya, lung cancer. There are certain mutations that are associated, pathogenic and associated with the lung cancer. But you'd also go to a clinic and a doctor diagnoses you with lung cancer. But not all lung cancer treatment protocol requires chemotherapy. You go through chemo, it's very brutal to the body. So you could find that through genome sequencing, you're able to pick that this mutation, this person X, this patient in Kenya, has this specific mutation, pathogenic mutation for lung cancer. That requires a drug, which is currently there are many and FDA approved. That requires a drug rather than being subjected to chemotherapy for so long, and you have a lot of wear and tear for something that should be treated with a drug. You understand? So yes, to our people in the Republic and across the world, whole genome sequencing is here with us. Yeah? And compared to 25 years ago when it was $3 billion, it's going lower. 2026, we could be talking about $100 for a whole genome. Come out and get to know your whole genome, the information in you. And we are looking at a future as Pan-African Institute of Genomic Sciences where we are going to have our own longevity clinics. And longevity clinics is where you walk in like the KFC or Starbucks concept or Java concept, where you walk in within 2 or 4 hours, you have whole information about you everywhere, even in all estates, in villages. So the moment you have, let's say, 5,000 clinics producing biological information, you know your risk early. You pick diseases at stage 0, stage 1. Picture a scenario where all types of cancers can be picked at stage 1 or 2. They would be easily treated.
For sure. And
that's why in our country, I have to say, there's some people who should have not died. Look at the CEO of Safaricom, Bob Collymore, the late Bob Collymore. He died young. Look at the CEO of Apple, Steve Jobs. He died young. The CEO of YouTube, with all that money, people streaming, she died fairly young, at age 58. And so many other people, even Barbara Ilodinga. Yeah? If whole genome sequencing done and predictive, look at Bob Marley. Yeah? Bob Marley died at a very young age. Look at music, the level where music would have been. So ideally, compared with all this, and in contrast, look at most presidents. Why do you think most presidents live into between 90 and 100 years old? It's not only their genes, it's predictive kind of medicine.
Okay.
Yes? And that's why, just by count in Kenya, you look at most presidents, they live longer. In America, you look at if there's a function or if there's a state funeral, the number of presidents that appear, most of them in their 90s, it's not by accident. And this is why we are proposing this symphony kind of predictive medicine. Know it early, be more proactive to ensure that you add 10 or 20 more years to your life, but following technology.
All right, we need to wind up the conversation. That has been an extremely informative conversation, a really, really informative conversation. So thank you for gracing us with your presence and for sharing the information that you've gotten to share with us here today. We're definitely going to plan on having you back, because now I would want to know, can we be able to slow down aging biologically? No, later on, not right now.
Yes.
Maybe that's a conversation that we can have later on. Now that we know we can be able to, live longer, can we live longer looking youthful? That maybe is something that we can look into next time. So I'll end this conversation here. Thank you so much to each and everyone.
Maybe just a word before we close.
Less than 30 seconds?
In less than 30 seconds, we are living in the right generation where there's information and technology. Genomics has come of age. If we predict diseases earlier, we are able to live and identify our risk. We are able to live much longer. Stem cell technology has come of age, where you're just taking your own cells, there's nothing ethical, and using it to treat yourself. Organ replacement, mitochondrial therapy is now real in clinics. Human beings are wired to live for 100+ years. Come to PEGS, let's talk more about how to live 100+. Thank you very much.
Okay, this is where we end it. My name is Vivian Ndegwa. Thank you so much to each and every one of you who has been tuning in. We usually do this each and every Tuesday morning where we talk matters health. So you are welcome to join us every single morning. Do enjoy the rest of your viewing. Goodbye.